Good evening, ladies and gentlemen. Tonight we start our right triangles unit by reviewing the Pythagorean theorem and then talking about how we're going to apply its converse to problem solving in geometry. So if you'll recall for a minute, the Pythagorean theorem is a way to find a missing side of a right triangle if you're given the other two. What we need to be careful of, the common mistakes with the Pythagorean theorem, is that people mistakenly put the hypotenuse in for A or B. The hypotenuse as the longest side must be by itself on the equal sign. It has to go in for C into your formula. That's the biggest thing. The other big mistake that people make is forgetting to take the square root as the last step of the problem. So let's say you're solving for your hypotenuse and your A is 1 and your B is 2. You square your 1, you square your 2, you add them up, you get 5. So then you think that the hypotenuse length is 5, but really that's equal to your hypotenuse squared. So to find your hypotenuse, the last step you would have to do is to take the square root. So all the Pythagorean theorem is saying is that basically the square of the legs added together equals the hypotenuse squared. We can see that illustrated over here with, I think they're white cheddar Cheez-Its. But in the middle, you can see that we've created a right triangle with a leg length of 3 Cheez-Its in length, another leg length of 4 Cheez-Its in length, and the hypotenuse is 5 Cheez-Its. If we square our sides, so 3 squared gives us 9, 4 squared gives us 16, we can see that 9 plus 16 equals 5 squared, which is 25 Cheez-Its. So the Pythagorean theorem is basically just saying the leg squared plus the leg squared equals the hypotenuse squared, thus illustrated by Cheez-Its. Some common Pythagorean triples. A Pythagorean triple is side lengths that form a right triangle that are all whole numbers, meaning no decimals or fractions. So some common ones are 3, 4, 5, 5, 12, 13, and 8, 15, 17. Um, you don't have to have these memorized, but it's kind of like the more tools that you have in your tool bag, then the more successful you'll be and the quicker the problems will go. The other thing that you should keep in mind is, ooh, I forgot one, 7, 24, 25, is that any multiples of these Pythagorean triples are also Pythagorean triples themselves. So for example, if I multiplied all my numbers by 2, and I got 6, 8, 10, that's a Pythagorean triple. If I multiply all my numbers, in this case by 3, that's also a Pythagorean triple. So as long as they get bigger proportionally or by the same factor, um, we still have a Pythagorean triple. So again, you don't have to memorize these, but it can help you save some work instead of having to calculate the Pythagorean theorem. If you have some memorized, then you can find a missing side just by having um, the sets memorized. Okay. All right, so before we can use the converse of the Pythagorean theorem, which states that if we have all three sides of a right triangle, or I'm sorry, I should say, if we have all three sides, can we figure out whether or not it's a right triangle? Whereas before, we said that we have a right triangle, so we know that the side lengths are related in this equation. Now we're using the Pythagorean theorem to figure out what kind of triangle we have. So if the a squared plus the b squared equals the c squared, then we know the triangle is right. That's when we have a right triangle. If the a squared plus the b squared is greater than the c squared, meaning they're not equal, these two are bigger, then the triangle is acute. And if those two sides are smaller than the hypotenuse squared, then the triangle is obtuse. So when we have three sides, we can figure out what kind of triangle it is by using the converse to the Pythagorean theorem. So basically figuring out the relationship between the sides. Now, one thing we have to consider is that sometimes not all three sides of that are given to us even form a triangle at all. This is really important. So if you take a look at this picture here, we have two sides of a triangle given to us. And then this third side we can see is just not long enough. Even if I kind of angled it up, we can see it's not ever going to fit over there. So not all side combinations make a triangle. So to figure that out, we always need to add up the two smaller sides that are given to us, because those two smaller sides have to be bigger than the longest side to make a triangle. Or else it's like trying to hug a fat person and your arms just won't reach. Okay, sometimes the sides just won't reach. And to figure out when that happens, you have to add up your two smaller sides and they have to be bigger than your third side to make them reach. Okay, always check this first before you ever do any Pythagorean converse problem. Okay, because we'll say, what kind of triangle is this? And you'll want to save yourself some effort. If it's not even a triangle at all, then you can stop right there and just say, oh, this doesn't even make a triangle. All right, if you have any questions, please bring them in. Remember, for full credit on this homework, you have to come up with at least 3 questions of your own, either based on this video, um, on questions that you actually have, or questions that you could pose to the class to see if other people in the class understood it. Have a great night. I'll see you guys in class.